Hello, today we're going to be talking about adding and subtracting fractions when the denominators are unlike, like thirds and fourths are not alike. And we're going to be using these two brownie pans. Imagine 2/3 of a brownie pan and 1/4 more of a brownie pan. Now, you might look at that fourth and say, well, I think we could slide that fourth into that space left over and it'd be almost full. But the truth is, even just eyeballing, we can see it's just almost full because the fourth is smaller than the third that's left over there. A fourth is smaller. So to be really precise about it, we can tell it would almost fill up that brownie pan, but it would probably leave a little bit left over. So we wouldn't be being as precise as possible to say that 2/3 plus 1/4 equals a whole brownie pan. To be precise, we need to use precise sized pieces. So we can't add these up using thirds and fourths and get a precise enough answer. We're going to have to find a size piece that is precise and that really represents 2/3 and can represent 1/4. One way to do this is to take the fourths and imagine splitting all the fourths into 3 pieces. Because the other brownie pan splits everything into 3 pieces, so let's split that brownie pan into 3 pieces too. And then go over to the thirds, and what if we split the fourths? We cut up those thirds into 4 pieces each. Now look at those size pieces. They are the same size, and there's one reason why that works. If you remember your multiplication arrays, we can see that 3 pieces across the top and 4 slices sideways in a rectangle array would make for 12 pieces altogether. And it's good to remember that with thirds and fourths, 12 pieces is a really precise way to represent both thirds and fourths. When we do that in a drawing or on an actual brownie pan, we can see that the 2/3 can be added to the fourth because we have, let's see, 8 twelfths and then 3 more twelfths. We have precise size pieces that are the same size now. So 8 twelfths plus 3 more twelfths is 11 twelfths. Very close to 1 like we thought, but not quite 1. So 11 twelfths. Twelfths was our magic number. Twelfths was the precise size piece that both could be split into. And we got that by looking at thirds and fourths and thinking, all right, if I split my thirds into 4 pieces and my fourths into 3 pieces each, I get same size precise pieces that are twelfths. You can do this without a drawing. You can do this using your equivalent fraction skills and writing down your goal of twelfths right next to the fractions you're working with. So instead of 2/3, you want a fraction that's equivalent to that. It means the same thing. And we realize that the 3 is multiplied by 4 to get 12, and you do the same on top. Same thing with the fourths to twelfths. I'm not going to go over how to do equivalent fractions. You guys know that pretty well. But you can see, even without a drawing, you come up with the same answer if you make equivalent fractions for 2/3 and 1/4 and add them up. I like to rewrite it so I can see my work, 8 twelfths and 3 twelfths. And it just helps me check my work. You can see that this works with lots of fractions. Really, the same process works with any 2 unlike fractions. Let's take 2/3, and let's say we want to take away a half of a pan. Well, we could take the thirds and split those into 2 pieces each, and split up the half pan, like the third pan, in 3 pieces each. And look, same size pieces, very precise. We got 4/6, and we've got 3/6. Subtract them, we've got 1/6. This works with thirds and fifths. I'm going to take my thirds pan, split it up into 5 parts each. My fifths pan, split it up into 3 parts each. And look, my golden number there, my common denominator, is 15. There's a multiplication fact in there. 3 and 5 is 15. You change them to equivalent fractions and you got it. Even with sevenths and fourths. And this is kind of a pain in the butt to draw. That's why I sped it up. It's hard to do the drawing. It takes a long time. But look, we've got 28 pieces if you want to stop and count them. Or just know that 7 times 4 is 28. You get your bottom number. Now, with a little bit of work, we can see, That works, and we have a precise answer. Fantastic, 19/28. Let's take a second to do another example. 4/5 minus 1/6. We know the fraction denominators are not equivalent, but we can use this quick trick with no drawing. We can say, all right, what are the multiples of 6? There will also be a multiple of 5. This is kind of another way of thinking about it. And of course we get to 30 as one of them. Oh, could have just multiplied 5 times 6, but it's good to check. Sometimes there's a smaller denominator in common. So I like to write out the problem sometimes vertically. So this way I can make my equivalent fractions right within the problem. So I know my common denominator is going to be 30ths. I can make my equivalent fractions side by side. I'm making sure I multiply the top and bottom by the same number for the 6th and the top and bottom by the same number for my 4/5. And then I can just do my subtraction. 24/30 minus 5/30. I get 19/30. And I'm happy scrappy. There are a couple things to take care of. You want to make sure that you do the multiplication correctly in both problems and you got the right multiplier. Otherwise, you're all set. And thank you so much for watching. Look at that guy, scuba diving welder. I know, well, he's not a scuba diving welder, but I've heard of scuba diving welders. You got your scuba gear, underwater, flame. People pay it. Nobody can do both of those things. People pay it buckets of money. It's a good job right there.